Good morning, everybody. How's everybody doing this morning? I'd just like to thank Kim for inviting me to come and speak this morning. I wear two hats. One hat is with the North Dakota State University Department of Mechanical Engineering, where I'm an associate professor there. And then the other one is the Chief Technology Officer of C2 Renew, which is a spin-out company from North Dakota State with my business partner, Corey Krejcia. And he and I started this company 2012, and we've been operating for the past 3 years. Before I dig into some of the technology that we've partnered with and what I'm doing on the academic side as well as the small business side, I'd like to take a step back for a second and talk about kind of our philosophy behind what we do, both on the academic side as well as within the company. If you look at the term sustainability, it's thrown around a lot, and it's not always has a precise definition. I mean, in its most rudimentary kind of definition, something that's sustainable will keep going, right? If it's not sustainable, it will die. But oftentimes, the term gets misused, or in certain cases should be used, and it's not. I liken it to the term green. Green is, again, a very odd word that people use in different circumstances to mean different things. I mean, you can have your biodegradable grocery bags made from bioplastics. Some people would say, well, that's a green innovation. You could improve the efficiency of your HVAC system in your house, and you could say by getting a new thermostat or whatever, and oh, that's green technology. You could paint your wall green, and you'd say, now that's green. You know, so there's a lot of different use and misuse of these terms. And so I'd just like to invite you to take a look at these two pictures for a second and think for yourself which one of these is sustainable. You know, you look at the picture on your left, and you see all these people on this train. I would argue that per unit fuel, per unit material, this is the most efficient way to transport people from one point A to point B. Okay? That's efficient. But is it sustainable? Obviously, you've got safety issues. You've got, is it lawful? No. You've got the societal impact as well. And then you look at the image on the right, and a lot of us drive in this quite often. It's very luxurious, right? One person per vehicle. You can go anywhere you want. You've got the freedom to take an off-ramp anytime. But think of all the fuel that's being spent and all the material per unit or person per unit material unit fuel being expended. And you talk to some automotive manufacturers, and they say, this isn't sustainable either. I mean, think of all the infrastructure that we constantly have to put in and maintain to have this luxury. And so I would argue neither of them are sustainable, because underpinning what it means to be sustainable are your three capitals. Your capitals of natural capital, which is fairly obvious. It's our materials that we mine. It's our materials that we grow that are rapidly renewable on an annual basis. But you also have your human and social capital, people. Are you satisfied in your job? Do you feel that you're able to grow within the job you're performing? Are you provided adequate training? Do you have a good, healthy work-life balance? You know, those are the social capital that Paul was really kind of talking about this morning. And then you've got your manufactured and financial capital. Obviously, what's the bottom line? Are you profitable or aren't you? And it's really where these three capitals intersect that you can have a sustainable business or a sustainable product or a sustainable system, if you keep all of these in mind. You know, some examples of you know, when bamboo came out in terms of products for flooring, everybody thought, oh, you got this rapidly renewable material that's so sustainable, okay? But then you looked at the farming practices, the harvesting practices throughout Asia, and then you start to question from a social capital, is it sustainable? the types of practices and what people go through to harvest that material, which is getting better because we're starting to improve on those aspects for a product like bamboo. But then we also can't get blinded either, and this is the fine line I walk between academia and my company, is that, say, for instance, all we did was focus on recyclable materials, and all we did is recycle the same material. And one could argue that's very sustainable, is keeping on recycling. But then what happens to innovation if you can't play with any material afforded to you? You know, some part of innovation would die if all we did was focus on recycling what we have, okay? So there's that fine line as well that we just have to be cognizant on. The bottom line is that moving forward, we have to not only praise those companies because of their bottom line, but we have to praise those companies that are also sustainable, okay? That's part of their culture as a company, that they're sustainable. And they meet and exceed expectations when it comes to natural capital, human and social capital, and your manufactured and financial capital. And so our philosophy when we're developing materials from a company standpoint or within academia is we really look at who we work with and network with and make sure that we are fulfilling these goals of natural capital, manufacturing capital, and societal capital. And for farmers and processors, it's got to be profitable. Otherwise, they're not going to do it. I grew up on a farm in rural North Dakota and spent many a day in a tractor, and we raised hogs as well. And there were certain things and a time clock that, because of the short growing season, that if I was expected to go, pick up extra straw, just one more time through the field or what have you, that time is precious, and so it better be worth what I'm doing or picking up. And so we need to work very closely to make sure that it is equitable, it is profitable. Our plastics and composites manufacturers, there's a learning curve there. And sometimes you have to change your manufacturing processes, or you have to tweak it just a little bit in order for the material to run. And so they have to be open, and a lot of these materials on the onset are going to be more expensive, okay? Because a lot of these materials get commodity, or they're basically a commodity, and without a large amount of volume, they are going to be more costly to start out with. But we have to get over that, and we have to keep utilizing these materials and integrating them more and more, because with higher volume, then the pricing becomes competitive. And your commodity groups are a huge part of the PR when it comes to these things. And you have to work closely with your commodity groups to support their efforts and their marketing of these new technologies. And then both the university and industrial researchers to developing new ways of doing different things. We all have to work together to form this foundation for OEMs to innovate with new materials. And what my group is very focused on is not trying to take these bio-based materials and create what looks like a synthetic product. We take these natural materials, we fully understand them through characterization through Fiber City, and we figure out what they can do, what they're capable of, and we embrace that and enhance that. And a lot of times, or the past couple decades, a lot of people, especially polymer chemists, were trying to take different types of vegetable oils and make it look like a petrochemical epoxy. And some of my colleagues now that I work with at North Dakota State University have stepped away from that and have looked at, okay, what is nature giving us, and let's see how we can enhance. And we have resins now that are 85% bio-based that perform better than petrochemical resins. And so we've got this new path, and unlocking those blinders a little bit has really brought on some unique innovations. And so we have what we call the Center for Sustainable Material Science at North Dakota State University, where we're focused on all aspects of different biomasses coming off the fields, whether it's proteins or fibers or oils, and converting those into building blocks that we can then create some unique biocomposites with unique properties. And this is a large effort that's funded by the National Science Foundation for the next 4 years now. It was a 5-year project, and we've got a large group working together, all the way from chemistry to agricultural engineering, to polymers and coatings, and then myself in mechanical engineering. And Lin Ping talked about some of the challenges for the different areas. In biocomposites, this is a very similar list. Lack of structural to semi-structural biocomposites with high renewable content. You know, you saw a few years ago Ford unveiled that they were going to use soy-based oil in the seat cushions of all their automobiles, and that's absolutely true. But you know what the percentage is of actual oil in the foam in your Ford seats? Anybody? Any guesses? 5%. And so it's a good step forward. Don't get me wrong, but we can do better. We can do better with looking at technology, like I said, looking at these materials differently and being able to synthesize new polymers based on what they are, not what we think they should look like. Lack in manipulating surface characteristics of natural fibers so that they adhere well to polymers. Again, that's an issue that we're working with the Composites Innovation Center on, as well as with Sunstrand, who also has a booth here. And doing some unique work, again, to find out which resins play well with which fibers and to optimize properties and performance. Lack in higher temperature performance is one issue with natural fibers, but we've also looked at some pyrolysis operations in order to stabilize the natural fibers and or herd or shive at a higher temperature so that we can introduce them into thermoplastics such as nylon 6,6 and some of your higher temperature, higher performance thermoplastics. And then a lack in the development of robust bio-based polymers. Again, there's a lot of work going on within academia, but also in the industry with companies like NatureWorks that are developing and continue to improve upon the properties of some of these bio-based thermoplastics as well as thermosets. And then again, Lin Ping pointed to the lack of standards for natural fibers and their biocomposites, and that's again something that we're working on. So in my group, like I mentioned, it's important that we fully understand the properties of these materials, fully characterize them, because at that point, then we can start combining them and trying to drive unique performance. Because with composites, you don't just design a material and then figure out how to use it. You design the material to suit a specific function that you want to create. And so by fully understanding these polymers as well as these fibers and combining them in a correct way, again, you can meet those specifications and that function that you're after. And so we've done this repeatedly at North Dakota State through some technology demonstrators, both on our own as well as in collaboration with the Composites Innovation Center. And the students are great. That's one reason everybody asks me, well, when are you going to leave the university and just focus on your business? And I said, never, because, for now, because I love the students. I love working with the students. They have such great ideas, and they're always like, hey, can we make this? And I say, sure. Let's see how it works. This bicycle that you see here in the image, this was one of my students was a cycling enthusiast. He competed a lot, and he wanted to develop a flax fiber, carbon fiber bicycle. And he did it, and he races with this thing. I think he's put over 500 miles on it now in different competitions. And it provides a lot of improvement in vibration dampening. And you can see with some of our bio-based resins in combination with natural fibers, we meet or exceed several properties that you would get from a traditional fiberglass reinforced petrochemical resin like polyester. And so the performance is there if you treat them right and you manipulate them in the correct way for some of these structural applications. And some of our current projects that are underway, we're continuing to do technology demonstrators. Again, my students wanted to make a bicycle helmet, a longboard, and a hammer. And you might be thinking, why a hammer? again, from the vibration dampening capability. It's really interesting. I was skeptical at first, and then they showed me the performance of it, and I was like, I like this. This feels good. Development of natural fiber standards and treatments, like I said, working with the Composites Innovation Center, Fiber City, as well as Sunstrand. We've got some work going on there. And the ASTM committee, D1317 for flax and linen. I'm on that committee as well as Ulven. Working with a podiatrist from Hawaii. This one was kind of interesting. He found me, I don't know how, but he has a two-piece composite design for a new orthotic that transfers a lot of energy back from the full gait cycle when walking. And he wanted to make it out of biocomposite instead of Kevlar and carbon. And so we're working with him, kinetics, orthotics out of Hawaii. And then also with some of my colleagues within coatings and polymeric materials, we're working on recyclable thermosets. And this is very interesting because the main knock on thermosets is that you can't reverse them, you can't recycle them. Well, he's developed a phototriggerable crosslinker that when hit with a certain wavelength of light will convert that thermoset back into its original monomer. And that's very exciting, that's groundbreaking. He got a lot of press for this around the world because now we can start looking at thermosets as well as thermoplastics for recycling. And then also working with another colleague in coatings, we're developing a stereolithograph 3D printer material made from 85% or more soybean oil and using a UV curable system, which is exciting because you can create some very good surface finish out of stereolithography, 3D printing, as well as some very high properties as well out of those parts. So that's basically on the academic side. Now I'd like to switch gears, constantly switching my hat to looking at C2 Renew and what we're trying to do with this spin-out company. And our main focus within the state of North Dakota is building the North Dakota bioeconomy. And we're doing that through things like connecting companies. Within our last 3 years here, we've connected over 12 different companies within the state of North Dakota. And that might not sound like a lot, but if you look at our population, we don't have a lot of population, so it is a lot on a per capita basis. And we've done this through these different bio-based technology demonstrators and developing real product that's going out the door. Developing ag tech is important to us. For me, having students that are graduating from our program that can stay within the state and keep working and innovating was a great goal and something I'm very proud of as well. And we have this industrial niche. If you look at where we're at in the supply chain, we're on the same level as traditional compounding or your resin distributors. We get our inputs from your large resin manufacturers such as Dow, but then Dow Chemical, but then we also get some of our resins from companies like NatureWorks who are developing all bio-based resins. And then we also take, what's unique about us then is taking these different agricultural inputs from processors such as Sunstrand and taking those materials, manipulating them into a new material for different molding operations. We've mainly been focused on injection molding products, but now we're getting into extrusion. We've done filament for 3D printers, which I'll talk a little bit more about in a second, but also looking into sheet extrusion. There's been a lot of interest in people wanting sheet stock of our biocomposites so that they can do thermoforming or die cutting for signage and things like that. And then finally, it goes into a finishing, assembly, and then out to the end user. Again, where our niche is that if you look at the material competency or the knowledge on your materials, those that are most knowledgeable are your resin producer. They know those resins inside and out. They know all their properties. You look at your big OEMs who can hire several materials engineers and have a staff to look and evaluate materials. They have a high material competency. And your small OEM, might have one material expert engineer within the company that provides that knowledge. And then you get down to the supplier and the molder, and here's where I get in trouble because I know some molders that are very knowledgeable, but I'm saying in general, they know what the data sheet is, and they know the molding parameters that they should run, but that's about it. And so what sets us apart is that we have a high material competency for where we're at in the supply chain. And so we can provide some very valuable information for the molder and for the OEM. We had a customer the other day that asked, okay, I want to make an electronics enclosure, so do you have dielectric properties for your material? And not right now, but we can go measure it and get it to you. And a lot of suppliers can't do that. They just put their hands up and say, I don't know, you're going to have somebody test it or figure it out. We figure it out. And so we started off in some very unsexy parts, things that are under the hood that nobody looks at, nobody cares about, and did some belt guards for Bobcat, some handles for John Deere, seed blockage monitor for Appario, some gears for Toshiba and their inkjet cartridges. And all we were doing here is giving them a lower cost material that performed just as well, and oh yeah, it's got some bio-based material in it. They didn't really care about that. They're starting to change that tune a little bit because like Bobcat and John Deere, they now have a sustainability initiative within their companies, and that's brought these materials to a different light, which is exciting. So it was from there that we kind of pivoted and we thought, okay, instead of just doing these, again, unsexy parts that nobody sees, why don't we work with companies that want to create a message with the material they're using? Utilize the material as a way to market their product. And that's when we started doing things like working with a company called Earthkind, who has an all-natural air freshener. They also have all-natural rodent repellents, and they wanted an enclosure. And so we helped them design and created a 100% bio-based material, hitting some specific Pantones, which was interesting with biomass, to create this air freshener holder that is sold in over 700 Lowe's stores throughout the southeast United States. So we're excited about that. We're expanding, and now Lowe's says they want 4 different color combinations, and we said, great. But no, it'll be exciting. Hitting different Pantones when these biomasses come in with different yellow and brown hues is really challenging. But we figured it out. And then also working with the company Bogo Brush, we developed an all bio-based toothbrush using polylactic acid from cornstarch as the main plastic, but then also flax chive, so the inner woody core. And Bogo is a neat company, a brother and sister duo that you buy one of these brushes online or in a boutique, and one brush gets donated to a community health organization. And so that's been interesting. And just recently, they were approached with an offer, huge offer, from a large dental insurance company to be either investment or purchased. So, and they have ambition to create 2 million brushes in 2017, which would be great for us because we can sell them more material. 3-Down Fuel, working closely with them, we launched 3 different 3D printer filaments. The first one being based off of coffee. We took the hull structure from the roasting process and we compounded it into plastic to make filament. We refer to that one as wound up. Buzzed is we're taking residuals from the beer brewing process and compounding that into a plastic that people can print and create. And then lastly, Entwined, which is our hemp filament, which is manufactured and sold now. And it's amazing if you look at social media what people are printing with these, and the amount of creativity and innovation that unique materials kind of unlocks for people, artists, or like I said, innovators, inventors, to create new objects and new devices utilizing 3D printing. It's outstanding. And that leads into one particular innovator down in Texas, Fort Worth, Texas. He's called Green Spring Technology. He started 3D printing pens, and it turned from 3D printing pens to, okay, I want to injection mold this pen. How do I get this material? Because he was getting his 3D printer filament from 3-Down Fuel, but he wanted to start injection molding it. Well, that's the beauty, is that we can provide that pellet then for injection molding. And so he came to us, he started injection molding these pens, and I've got one at the booth if you want to check it out later. And what was really special about this is it was used to sign some new hemp legislation in Pennsylvania a couple weeks ago. And they used hemp paper, hemp pen to sign off on their new legislation, which was exciting for us. Just a small little incident or event, but it means so much if you look at it from a big picture. That also led us to thinking, how can we capitalize not only on, we like this idea of developing material and supplying it to different molders and for other people's products, but why not vertically integrate and create something of our own? And so that's when we decided to come up with a biocomposite travel mug. And we first started producing them with coffee, so you could have your coffee mug made of coffee. But now we've launched our hemp coffee mug as well. And I believe Kim has them for sale out at the desk where you registered today. And so it kind of gives a neat texture to it. And so that's exciting to have a product of our own out there as well. What's next? Boy, we are getting calls from all over the place, as far as from toy manufacturers we've been molding with to components in porta potties. I mean, you can't get much more diverse than that. To ammo trays. Somebody wanted to make their ammo trays out of biocomposite. Okay. Instrument cases, components on hot water heaters, components in windows. Getting a lot of calls from medicinal marijuana companies who want our materials to go into the packaging, the containers for medicinal marijuana, and as well as signage for dispensaries. We've got 5 different people who are asking for our sheet stock so that they can make some signage for their companies. And so it's exciting, but a lot of these are head scratchers at first, and then convincing everybody, no, let's take a shot at it and see if we can make it work. And so with that, I'd like to wrap up by acknowledging the different funding agencies and partners that we work with. Again, none of this would be possible without the funding that we get, and the students that work with me, and the former students that I've hired to run my company. They're tremendous and the reason why we exist. So thank you very much.